So in this course, we've now covered a number of ways of checking for statistically significant associations between variables. And these are the kinds of tools that are used when we're trying to determine if there's a cause and effect relationship. Now, the tools that we've covered are things that are relatively simple, but they do work for some very common situations that you come up against, and they are adequate for what we call field experiments that you might do in a real organization, or for analyzing real data that might be collected. When we get into serious scientific research, we often have to do things that are quite a lot more complicated, and we'll only be really hinting at that kind of thing in this course. But if you want to do those more complicated things, you're going to have to go and learn a whole lot of new tools, and that's really a matter that would take, at least a couple more courses. But let's have a look at some of the things we've covered. A little later I'll introduce probably one more technique. I'm just going to start with something that we did fairly early on in the course, and that was that we looked at correlations between two quantitative variables. So I've got some simulated data here about the relationship between job satisfaction and job performance. This is something that is really studied in the real world by real scientists, and I've simulated data here with a 0.3 Pearson correlation, which apparently is reasonably typical for in these kinds of studies. So you can look at the scatter plot there, just eyeballing it. You'd say, well, job satisfaction doesn't give me a huge amount of information if I want to predict job performance. You can see I put a regression line there, you can see that it's a slight positive slope. So there is it appears that there isn't a positive association. This tells us nothing about the direction of causation. It could be that job performance is causing satisfaction, or satisfaction is causing job performance, or maybe it goes both ways. There's nothing there to tell us. Okay, now I can tell you that that correlation is statistically significant. So I'm pretty sure I've mentioned before there are ways of calculating a 95% confidence interval for Pearson's correlation, and that is the 95% confidence interval for that data. So it's telling us that, we're 95% confident that the correlation between job performance and job satisfaction is in the range 0.17 to 0.42. So it's somewhere in the weak to moderate correlation range, using Cohen's rule of thumb about Pearson's correlation. And I've also done a linear regression here, so you might have to refresh your memory about how to read these things. They're reported in various ways, but the way this is presented, job performance is the dependent variable, that's here, and job satisfaction is the independent variable. The linear regression is just estimating a linear equation that relates the two. That's this thing here. So the estimate is that job performance is equal to 0.25 times job satisfaction plus a constant or intercept of 47.5. And then there's a whole lot of error around that, which is why we've got this kind of scatter of points rather than points sitting on a line. I should have mentioned that with this kind of study, you'd be measuring job satisfaction with some kind of questionnaire probably that the workers would be filling out about their job satisfaction. And the job performance can be measured. There's quite a lot of different ways that people try to measure that. One is to get supervisors to fill out a questionnaire rating their supervisees. But there are other ways. If it's if they are workers in sales, for example, you might use their sales revenues or something as a measure of performance. Anyway, when we look at linear regression, just a little refresher here, we have this number, the coefficient. It has 3 stars next to it, so I've told you about stars before. This follows the convention that 3 stars means that there's a p-value of less than 0.01. 2 stars means less than 0.05, and 1 star means less than 0.1. There's the sample size 200. They call it observations there. And key thing we're interested in here is the adjusted R squared, which is 0.085. So what that's telling us is that if this is a linear relationship, then job satisfaction gives us about 8.5% of the information we need to predict job performance. That's not a huge amount. So your conclusion you draw is, look, there's a signal there about the relationship between job satisfaction and job performance, but it's surrounded by a lot of noise. And so although the association, the correlation, is statistically significant, it's not particularly strong, and there could be other causal factors involved that we would have to take into account in some way if we wanted to make a claim about a causal relationship between job satisfaction and job performance. Or it could be there's just a whole lot of randomness in the relationship. All right, I'll end there, and then we'll continue looking at other approaches to association.